everyone, we're going to talk about polar coordinates, but first we're going to go back to what we already know. When coordinates come to mind, you should be familiar with rectangular coordinates already, which are regular xy coordinates. So if I were to tell you to plot the points 6, 6, and -4, 0, you could probably do that pretty easily and fast, right? You'd know that if you want to plot the point 6, 6, that you go out 6, up 6, plot your point where those match up, right? And then for -4, 0, you would know the x is -4, so on the x-axis we go towards the left 4. We don't go up or down at all because of the 0, and we plot our point right there. All right, so this is the rectangular coordinate system. Somebody had to create the rectangular coordinate system, right? Someone came up with this. So it should be easy to buy into the fact that this isn't the only coordinate system that we could use. There's others, and the one that we're going to talk about is the polar coordinate system. For the polar coordinate system, we want to look at define points, the location of points by their distance away from the origin, and then by the angle that's created in standard position, whose terminal side would contain that point. So let's try to find those two things. If I wanted to find the distance of this point right here away from the origin, that would be, distance is always the straight line distance from the one location to the next. So I want to find that length right there. Think about how we could find that. Can't we make a triangle out of this? And what would these side lengths be? Well, we went out 6 and we went up 6, so we have 6, 6. This is a right triangle now, so we could use the Pythagorean theorem, right? So 6 squared plus 6 squared equals, I'm actually going to call this r, it's r squared. So we get 72 equals r squared. And then we'll take the square root of both sides. So r is the square root of 72. You can break that apart, right? So the square root of 72 is really the square root of 36 times 2. And the square root of 36 is 6. So we get 6 square root 2. So we'll call r. So in polar coordinates, this length from what we usually call the origin to the point is going to be called r. We also now want to come up with this value here, theta, so the angle. And looking at our picture, how can we figure that out? Well, across from theta, we have 6, so that's the opposite side, and then next to it, the adjacent side is 6. Opposite over adjacent is tangent, right? So, or maybe I'll write this over here where I have some space. Tan theta would have to equal 6 over 6, so tan theta would have to equal 1. Okay, do we know the exact answer for that? We want to give our answer in radians. I promise she's okay. All right, so we want to give our answer in radians. If you look on the unit circle, you should have your tangent values written along it. Tangent's equal to pi over 4 in the first quadrant, where tangent's 1. Or theta is equal to pi over 4 in the first quadrant, where tangent of theta is 1. All right, so we have that. We have that. Now let's go ahead over here. We'll do the same thing. What would the distance from the origin be here? We can just count to it, right? Because the straight distance is 1, 2, 3, 4. So r is equal to 4 for this one. Theta is going to be the angle from the positive x-axis over to our point. What angle would that be in radians? That is 180 degrees. I just said radians though. That's pi in radians. All right, so that one we could just look at and figure out without having to work it out too much. So what this means actually is that 6, 6 in rectangular coordinates is equivalent to, or maybe I'll say this, can be written as six square root 2 comma pi over 4 in polar coordinates. Okay, so that's one takeaway here. So that when you write polar coordinates, you always put the r value first, and then you put the theta value after. And then we have one more result that we got, negative 4, 0 in rectangular coordinates can be written as 4 pi in polar coordinates. And it turns out actually that there's, this isn't the only way that you could write these points in polar coordinates, but we'll explore that concept a little further when we go into the next part of the notes. Okay, yeah, I think I'll stop there for this section, and then we'll pick up in a new video.